Hello students, welcome to JSM Learn. In this video, we are going to discuss some of the previous IIT JEE Main questions and their solutions from the chapter Structure of Atom and particularly from the selected concepts Hydrogen Spectrum. So let us see the questions one by one. So in this one, statement type question they are giving here. So two statements they are provided and they are asking us to select this statement, choose the correct answer. So from these statements, you have to identify which of these are true or false. So now let us see the first statement. The information they have given here as when an electric discharge is passed through gaseous hydrogen, the hydrogen molecule dissociate and the energetically excited hydrogen atoms produce electromagnetic radiation of discrete frequencies. So now whether this line statement, which one given here, true or false, let us see. So what they are doing, electrical discharge. Just think some light is passing on to the hydrogen molecule. So hydrogen molecule is present inside a tube. So on passing it, so what is happening? It is exciting. So dissociating and energetically exciting. So dissociating means we can write here as what? Hydrogen is getting dissociated and producing like this. Okay. So now each hydrogen atom, so where the electron is there, it is exciting into higher energy level. Okay, as we know, in the higher energy level, electron is not going to be stable for longer time. So as a result of it, again that excited electron is going to come back into its original state, that is ground state. So while it is coming back, it is going to emit the radiations. So those are only going to form the discrete lines, which are having the discrete frequencies, fixed frequencies they will consist. So that means the statement 1 is true. True statement. So now let us see the second statement what they have given here. The frequencies of second line of Balmer series obtained from helium plus is equal to that of first line of Lyman series obtained from hydrogen atom. So now we have to identify the frequency of He plus in the which series they have given here, Balmer series. So Balmer series. So second line of Balmer series means what? In Balmer, N1 shell is what? 2. So second line they are saying that means N2 will be 4. Next, whether this frequency of helium plus is equaling with the frequency of hydrogen. In case of first line of Lyman series, they have given the information. That means in Lyman series, first line is 2 to 1. Okay. So first line means N1 value is 1 and N2 value is 2. So these two frequencies we have to identify. So now let us see. As we know the formula, Rydberg formula, 1 upon lambda is equals to R into Z square multiplied by 1 upon N1 square minus 1 upon N2 square. 1 upon N2 square. So now, as we know, mu is equals to C upon lambda. So in this case, 1 by lambda can be written as what? Mu upon C. Mu upon C. So here in the place of 1 by lambda, I am writing mu upon C means we can write this one as mu is equals to C into R Z square 1 upon N1 square minus 1 upon N2 square. So here first one I am doing frequency of He plus. Second line of Balmer series they have given here. So just keep these constants like these only. C into R. Z is what? For helium, second shell, atomic number is 2. 2 square. 1 upon. So second line of Balmer they have given. So N1 value is 2, N2 value is 4. So now substitute these values. N1 value is 2, 2 square minus 4 square. So here CR 2 square 4 1 upon 4 minus 1 upon 16. So here on LCM, we'll get this value as what? 16 LCM. So 3, 4 ones are 4 fours are. That means we got helium frequency of helium plus is equals to Cr, 3Cr upon 4. So now we have to cross check with this value with the hydrogen. Okay. Lyman series of hydrogen. So now whether that frequency is same or not. So frequency is equals to Crz square into 1 upon N1 square minus 1 upon N2 square. Okay. So now is equals to Cr. This is for what? Hydrogen atom. This is for hydrogen atom. Cr into Z value is 1 upon, as here the values as what? Lyman series first line. N1 is equals to 1, N2 is equals to 2. So substitute these values, 1 square minus 1 by 2 square. So here you will get the value as Cr into 1 square 1, here 2 square 4. So on taking LCM, we will get the value as what? 3 by 4. So now we can see frequency of hydrogen we got as what? 3Cr by 4. So which is matching with the frequency of helium's Balmer second line. Okay. So both the values are correct we got. That means statement 2, whatever they have given, that one also true. So both the statements 1 and 2 are true. Option C is correct answer in this case. So like this you can solve very easily. Now let us go for the next question. Copy these and comment your answer below. See this question in the second. Consider the following spectral lines for hydrogen atom they are saying. So here let us solve first line of Paschen series, second line of Balmer series, third line of Paschen, again fourth line of bracket series. So we have to see for what? The correct arrangement of the above lines in ascending order of energies. So as we know the formula for energy, 2.18 multiplied by 10 to the power of minus 18 Z square multiplied by 1 upon N1 square minus 1 upon N2 square in joule per atom units. So now let us see here, as they are saying hydrogen atom, Z can be written as what? 1. So now on substituting each and every value, this value is going to be constant all the time. So instead of solving for this, I am considering this value as x. Okay. So let us solve the next question. So for the first one we can write the first line of Paschen series they are saying. For first line of Paschen series means N1 can be written as what? Third, and N2 value is what? 4 in case of Paschen series. So on substituting these values in the above equation, delta E is equals to x, Z value is 1 square multiplied by 1 upon N1 square, 9 minus 1 upon N2 square. This can be written as 16. So whose value we are going to get this as 0.048x. So now same way if you solve for the second one, so delta E for second line of Balmer series. Second line of Balmer series means what? N1 value will be, Balmer series means 2 square minus, second line means 4 square. So 2 square minus 1 by 4 square. So on simplification here 1 by 4 minus 1 by 16. On simplification of this you will get the value as 0.187x. Okay. So now let us see for the third one. So here in this case again formula I am writing delta E is equals to x multiplied by, so 1 upon, now look at it, third line of Paschen series. third line of Paschen series means what? So it is coming into third line. So 3 square minus 1 upon 6 square. In Paschen series, N1 value is what? 3 and N2 value is 6. So now from this we'll get this as 0.083 x. So now let us go for the fourth one. Delta E is equals to x into 1 upon. Now fourth line of bracket series they have given here 4. So fourth line in bracket series means it is coming from 8th to 4. So 4 square, 8 square. So on simplification of this, 1 upon 16 minus 1 upon 64 will get the value as 0.046 into x. So if you arrange all these, so if you see energy of second one means second line of Balmer series very higher comparing with all these. So second one will comes first. Okay. Then after if you observe, so 0.083 that is of third one. That means third line of Paschen series is going to be have more energy. Then if you see first one, first line of Paschen series which is consisting 0.048 into x. So first one, then the remaining one is 4. Okay. So fourth statement, fourth line of bracket series is going to have the least energy. So let us see 4, 1, 3, 2. So option C in this case is the correct answer. Let us see the next question. Yes, students, let us see the third question. The wavelength of spectral line obtained in the spectrum of lithium plus 2 ion, wavelength they are asking, when the transition takes place between two levels whose sum is given as 4 and difference is given as 2. So lithium plus 2 means we can write as per the given data, we can write Z value, atomic number, lithium is what? 3. Next, their sum is 4 means N1 plus N2 is given as 4 and the difference is N2 minus N1. Difference is what? They have given as 2. So now on solving this one, we can solve this as, from this I am writing the value of N2 can be written as what? 2 plus N1. Okay. So this value I am substituting into this equation. So N1 plus at the place of N2, 2 plus N1 is equals to 4. So from this 2N1 is equals to 4 minus 2, 2. That means N1 value will be what? 1 we got. So on substituting this N1 value in this second one, so what we are going to get? N2 minus N1 is equals to 2. N2 minus 1 is equals to 2. That means N2 value is what? 3. We got N1 value as 1 and N2 value as 3. So now let us see. They are asking for what? The wavelength of spectral line. So wavelength formula we have from the Rydberg formula, 1 by lambda is equals to R into Z square 1 upon N1 square minus 1 upon N2 square. So that is equals to Z value is 3 whole square upon 1 by N1 square. Here the N1 value is 1 and N2 value is 3. So 1 square minus 1 by, we can write this one as 3 square. So now from this R into 9. Here 3 square 9. So on LCM we will get as what? 9 minus 1, 8. So 9 9 gets cancelled. Here 1 by lambda value we got as R into 8 or 8R. So from this if I am writing the value of lambda, wavelength can be written as what? 1 by 8 into 1 by R. Separately I am writing here. So the value of 1 by R, which one we know that? R is equals to 1 upon 8 multiplied by 912 angstroms we can write. So from this on simplification we will get the wavelength value as, just look at it, 8 ones are, so 114 times. So lambda is equals to 114 angstroms. But look at the options they are given in centimeters. So now from here we can we can convert this angstroms. As we know, 1 angstrom unit is equals to 10 to the power of minus 8 centimeters. So on substituting that, 10 to the power of minus 8 centimeters. Just check for the options. Nowhere it is consisting 10 to the power of minus 8. So now, here in this both. So now look at it. I'm converting this one. 1.14 multiplied by 10 to the power of minus 6 centimeter, it can be written as. So according to that, option D is matching with this. So which is the correct answer? So like this you can solve. Let us see the next question. So question number 4. Here they are giving the information about the wave numbers of the 3 spectral lines of hydrogen atom. Again they are providing what? Atomic number 1 are considered. So wave numbers. Identify the set of spectral lines belonging to the Balmer series. So Balmer series related, we have to identify the spectral lines. Wave number, we have the formula is what? Mu bar is equals to R into 1 by N1 square minus 1 by N2 square. And they are given as what? Balmer series, means N1 value is 2. This is fixed. So now let us check. Firstly, I am taking the N2 value as 3. And N1 value they have given. Balmer series means this can be taken as what? 2. So now, on substituting the values, mu bar is equals to R into 1 upon N1 square, 2 square minus 1 upon 3 square. Directly writing 9. So on simplification, we will get the mu bar is equals to R into 36. Okay, 9 minus. So first line value we got as what? 5R by 36. 5R by 36. So which is consisting in option B and option D also there. 5R by 36, 5R by 36 first value. Now let us see the next one. So by taking the N2 value as 4 and N1 value as 2 for Balmer series. So by substituting all these values, mu bar is equals to R into 1 by 4 minus 1 upon 16. So on simplification, mu bar is equals to 16. So 3R by 16. So mu bar value we got as what? 3R by 16. So here you can see no option is consisting after 5R by 36 value, 3R by 16. So directly you can go for option D in this case. Though if you want to check for the third one, third line, in the case of third line in Balmer series means N1 value is 2, N2 value is 5. So again on substituting these values, mu bar is equals to R into 1 upon N1 square minus 1 upon N2 square. So this can be written as what? 25 into 4, 100. So 25 minus 4, 21. So 21 R upon 100. So which is the correct option here? D. So like this, you can select the correct answers. Thank you all. Follow our channel for more solutions like this.